So I'm just going to summarize for the camera, for the recording, that we have our metalloids, and they have properties in between metals and non-metals. They are shiny like metals. They are brittle like non-metals. So they're shiny, they're brittle, they are solid at room temperature. That's like metals and some of the neighboring non-metals. And the one that you absolutely must know is that they are semiconductors. You are not responsible for anything else other than knowing where they are. So you don't need to know that they're brittle. You don't need to know that they're shiny. Okay? You just need to know that they are semiconductors. Now, what does it mean to be a semiconductor? What do you think they are conducting? They're conducting electricity.
Does that mean
Pardon me?
also heat or gas?
Just electricity. They probably also do it with heat, but we're going to stick with electricity here. But they don't conduct electricity super well. And why that makes them really good for computer chips, I am embarrassed to say that I really don't understand it. I think it has things to do with like little electrons jumping up and down bands and stuff, but it is really beyond anything I ever learned in university. Yeah? So if you want to know why semiconductors are really useful, you will need to go and take some courses on that, okay? Because I'm not going to be the one to teach you that, certainly not in grade 9. I know a little bit about them, but I can't even teach it to you because it has to do with P gaps and N gaps, and that makes no sense to you, right? So I'm like, okay, I won't even mention that. They conduct electricity, but not super well, and that makes them really good for computer chips or phone chips. So all the processing power in your phone, all the processing power in the computer is due to those metalloids and their semiconductive abilities. Now, if you really want to get technical, they kind of peter out down near the bottom. Like if you were to put astatine and tennessine, whatever the heck it's called, I would not get mad at you, but we really don't actually know because when we get down this far, everything is so radioactive, it does not really hang around long enough for us to see what properties it has. And whether it is a non-metal or a metal depends on its properties. Yes? So we're like, probably they are because they're sort of in that same area, but we don't know for sure because they don't stick around long enough. Okay, let's see. You are responsible for memorizing where the metalloids are. You should know that their properties are in between, but you don't have to know them specifically. And you should know that they are semiconductors. And that's it. So now you know everything in theory. You have been taught everything you need to know for Wednesday's quiz. Would you like a few moments today? Would you like to get a practice quiz right now and write it right now? Okay. Why don't I get that handed out to you? Actually, you know what I'm going to do? If you want the regular version, it's the one that says regular. If you want the one that is enriched, it's the one that says, and actually, you know what? Do you want to go around and just see if they want the enriched? They can ask you. I'll go around with regular. Catch a turtle, come around with the enriched.
Would you like the enriched?
I'm just sometimes that anyone here for regular? No.
It's not, yeah.
Like 3 years ago. Yeah. You get yeah. You'll get my periodic. Okay. What's ceiling for you? Yo, I forgot her name. It's like the owl. No, that's how we got sorry. You want to find out? Let's spell that out. Anybody want to read the pitch? Okay. Yeah. Oh, anyone else want a regular quiz? Oh. 15 and 6.
Regulars are coming around, okay?
Oh, I don't know 50. Okay.
Yes.
Wait, I don't know if 50 is worth it.
I lost my book periodicity.
Anyone need a periodic table? You will be given a periodic table for the quiz, but it won't have any notes or shading on it. Groups are oh, I know this. What do we call all the elements of the I was like, what? Now, she said every next time it's scary. You need to remember it. Oh, okay. Something. I forgot. And she was in the middle. Oh, you're looking like a flop. Just everything that's that's on the other side of the yeah, except for yeah, right. It's a lot of shading.
No, actually,
Oh, you have to go. Yeah. What's the 2 elements for which transit?
yeah.
Yes.
Oh, that's it. Totally remember. Number 3.
Okay. So we're at
I totally
Any questions here?
I totally know. Yeah. Oh, it's the word we literally use. Subconductors. Semiconductors.
people, for the enriched quiz practice test or quiz, for the question number 1, you only have to answer the columns which have the letters on them. So ignore the 13 and 14.
Metals are magnets. Great. Okay. All right. So yeah, I mean, we have it. Yeah. What's mercury? It's like H something. Yeah, it's H. What? Here. My friend owns you, so. Okay. What's the option for that?
Welcome.
They call it gas. Gas and
Shape all the metals, doing all the non-metal gases. If you've done it that way, okay, so you're going to all the non-metal.
what is gas? Gas is and then like bromine. No, gas is and then bromine is like wait, right? Wait, yes, wait, I forgot half of it. Hey guys, why did I cook off this actually? Yeah, it's because I saw the things. I did not study. When I cook up in what's the other thing? Yeah, I mean, other my things. Malibu, there's 7. Yeah, I forgot one of them. Which one? It's like the one that's not Malibu. The one that's like, yeah, that one. I'm done. Not even drop it there. Appearance rather than all of them. So what episode are you supposed to yeah.
If there are any questions that are coming around, okay?
Yes.
Yes, Jordan, coming around.
What's the last one? I got.
That's it. Last two miles.
Oh, yeah, state of Virginia.
I'll be right back. If you would like an answer key, I'm just putting them right here. There's the enriched one and the regular one. So if you have finished and you would like to check with the answer key, you can go grab one off of there.
I feel like the 13, 14,
Yeah.
the rose for me. Yeah, I was right. It was rocks. Or it could be the other way around.
Go again. Okay.
And you don't have to do he said nitrogen has to be gone, right? Chromium, that's what that is. So you know that the. Hey, teacher, do something. Yeah.
Okay, this is.
Weird.
But all respect each other.
Yeah.
I don't think.
Which is why for me. Yeah. No, I know. Okay, this is how we guard it. We've been bad, you know, I went out of that pretty fast. Okay. So this is the hard way. I know this is probably one, this one. So.
If there are any questions, I'm here, okay? Yes, you are.
You want me to say on? Yeah. Oh,
Yeah.
You should tell what density is, yeah. So high density magnet.
If you're done with quiz, get an answer key and check your work. No, it doesn't matter. And quite frankly, the order doesn't matter as long as you get them all. Yeah.
Do you have to write the description for these?
Yes. So you would want to say what is ductile, right? And not first week, it's gonna be like yeah.
So we should also write definitions of
Yes. Folks, you should also be writing the definitions for the properties when you come across them. If you're doing the regular version, it's pretty much implied because it's part of the question and you got to come up with the word. Yeah. Which version? Regular? Would anyone like another one of these?
forgot the word I was gonna write. It's like math and physics.
You want me to do that for you? So fun. No, I don't think so. So it doesn't matter.
Oh, yeah. Yeah. I will like swing it around.
Yes.
And that looks so much. That looks good.
Yeah, absolutely.
Anyone else want
That's your practice.
It's good to take home to practice.
Oh, yeah. Oh, yeah.
That's so fun. That's good stuff. Good. I'm gonna hear how you do. That is wrong. Just talked about that today. Yeah.
It's like your fried chickens and fried eggs. Wait, oh my.
That everyone.
And the whole line and find out. No.
Why is that?
Okay, so you're ready.
Basically,
Are you Matthew? All good here.
Yeah. Known to make this so I would like pour some. I'm better at it now. I would like. Maybe.
You ruined it, bro. So I love it. You said hair wash that shit. You saw. Watch it again. Rachel lip. That list. Do you guys look here?
Any questions? Any
I'll take it. What are you doing? Oh, no, Oh, I know. It's so annoying. I actually tried. Oh, it's really hard. Yeah. We'll be back. Oh my God. I'm ready for the next year.
I was like,
It's literally all she goes. It's literally right for me. Of course, yeah, I'm not. Worse. Okay. Oh yeah. What? We open it up. And oh my God.
Okay, friends. We've all had a chance, I think, to at least complete it once. Yes? So we will now go on to we're going to hang out with Tyler DeWitt a little bit more.
Oh, not that guy.
Oh, not that guy?
Interesting.
Okay. So we are on page 86. Now we have two versions of an element here, and he has counted them up, and we have 5 protons on the left. This is page 83, if you missed that. And the element on the right, we also have 5 protons. Are these the same element or different elements? They are the same element. If you have the same number of protons, they are the same element. But this one has 5 neutrons and this one has 6 neutrons. That means that they are different versions. What do we call different versions of the same element? See if you can tell your partner, what do we call different versions?
What is that? Is that from
Those are called isotopes. What makes one isotope different from another isotope? Have a chat with your partner. What makes one isotope different from another isotope?
Yeah.
They have something different about them. Is it the number of protons? No. Is it the number of neutrons?
Yeah.
Yes. Different isotopes have different numbers of neutrons. They have something else that's different as well, that is caused by them having more or less neutrons. Different mass numbers. Because, of course, the mass number is equal to the protons plus the neutrons. Okay. So now, having dealt with that part, we are going to, after everyone's finished writing, go hang out with Tyler for a little bit. Okay. No, we can't hear it. We need subtitles. I'm getting there. I'm getting there. Give me a second. Okay, here we go.
Let's talk about the difference between mass number and atomic mass. These things sound very similar, but they're actually very different. Just so you know, atomic mass can go by other names. Sometimes it's called average atomic mass, or relative atomic mass, or even atomic weight. Maybe your teacher calls it one of these. For our purposes, in this video, we're just going to call it atomic mass. So we're talking about the difference between these two things. Let's start by talking about mass number. So up here, I've got two atoms. They've got protons and neutrons in their nucleus, and I'm particularly concerned with the number of protons and neutrons that there are. So this atom over here has 5 protons. The protons are these red circles. We can count them up. 5 protons, and the neutrons are these blue circles. We could count them up. We got 5 of those.
By the way, what element is this? See if you can find what element this is and tell your partner. Who is it? It's boron, because boron has an atomic mass of 5. Beautiful.
This atom over here also has 5 protons, but it's got 6 neutrons. So, mass number is the number of protons plus the number of neutrons. So this atom here has a mass number of 10. 5 plus 5. And this atom over here has a mass number of 11. 5 plus 6.
So could you please fill in those mass numbers for those two atoms on your sheet? Mass number on the left is 10. Mass number on the right is 11. And all you do is add the protons and the neutrons.
Mass number tells us how many protons and neutrons are in the nucleus of an atom. But it's also important because it gives us an idea of how much the atom weighs. You might remember, we've said before, that 1 proton or 1 neutron weighs about 1 AMU, 1 atomic mass unit.
How much does an electron weigh? Basically nothing. 0.0005 something.
So,
yeah.
If you have a mass number of 10, 5 protons and 5 neutrons, your atom is going to weigh about 10 AMU. If you have a mass number of 11, that tells you that the atom here weighs about 11 AMU. These atoms both have electrons, but electrons are so tiny and they have such a small amount of mass that we don't even worry about the mass of electrons when we're weighing up stuff to determine how much the larger atom would weigh. So 10 AMU, 11 AMU. So that's mass number. Protons plus neutrons, and it gives you an idea of how much the atom weighs in AMU. Now, let's talk about atomic mass. You might notice that both of these atoms have the same number of protons in their nucleus. 5 protons here and 5 protons here. This means that they are the same element, right? Because the number of protons an atom has determines what kind of an element it is. So, we can look on the periodic table to find out what element these atoms are. And it turns out that they're boron, because boron up here has an atomic number of 5. 5 protons, and your boron.
What is that number at the bottom? That is the atomic mass. Is that the mass number?
No.
No, because what is mass number equal to? Protons plus neutrons. Is it possible to have 0.8 of a proton? No. So your mass number either has to be 10 or 11, depending on how many neutrons there are. So for grade 9, you're really not going to use this number at all. Okay, so the number on the bottom of each square of the periodic table, you can just ignore it. You will use it a lot in chemistry 11, but for science 9, it is useless to you. It will only confuse you and get you wrong answers. So any of your answers in those charts, you know, that you started filling one out on Friday, we're going to be doing a whole bunch more of them. There should never be a decimal anywhere. No decimals ever. Okay, because we're always talking about whole numbers of particles.
So, both of these atoms are different versions of boron. They're different isotopes. An isotope is a word that just means a different version of an atom that has the same number of protons, but a different number of neutrons. We can give distinct names to these two isotopes or versions of boron.
Yes. Can you remember how we would name these two versions of boron? See if you can tell your partner, what would we name the version on the left? What would we name the version on the right? Here's a hint. Both of them are going to start with boron. Okay, it's going to say boron. What comes after the boron? A dash. What comes after the dash? The mass number. So you're going to have, I'll let Tyler finish it up here.
This atom over here is an example of boron 10 because it has a mass number of 10, 5 plus 5. And this atom here is an isotope of boron called boron 11.
So finish filling in those boxes, okay? The one that says boron dash, fill in 10 and 11. And if you're not moving your pen, I know you're not writing it down. Hudson, Jordan. What are you supposed to be writing down? The 10 and the 11. Okay, good. Logan, did you write it down? The 10 and the 11? Okay, just in case we missed it, let's go over here. And on our, oh, there's nowhere to write it. We're on the next page. There we go. That's why. We're on page 87. Boron 10, boron 11. My apologies. That's my fault. Okay.
5 plus 6 has a mass number of 11. So, there are billions and trillions and gazillions of boron atoms in the world. If we could pick one up at random, it could be either one of these two types. Okay, it could be a boron 10 atom with 5 protons and 5 neutrons, or it might be a boron 11 atom with 5 protons and 6 neutrons.
Question for you. Which isotope do you think is more common? Boron 10 or boron 11? And why? Have a chat with your partner about that. Which one is more common? Anyone want to give that a go? What would we do without you, Miriam? Okay.
Sorry.
No, it's all good.
You repeat the question.
Which isotope is more common, boron 10 or boron 11?
Boron 11 because 8 is closer to 11 than 10.
Yeah, 10.8 is closer to 11 than it is to 10, so we probably have more of the boron 10. No, 11. Sorry. Oh my gosh. What's wrong with my brain?
So boron comes in these two versions. Now the thing is, there is not an equal number of boron 10 atoms and boron 11 atoms. In fact, if we pulled 50 boron atoms at random and represented them here, we'd see that the majority of the boron atoms are boron 11, which I'm indicating with little orange circles here. Okay, most of them are boron 11, and only a small minority of them are boron 10 atoms. We can look at this on a pie chart just to get this point home, and you can see that the vast majority of them are boron 11 with a smaller amount that's boron 10.
Now, we are going to skip the bottom of page 87. If you're interested in that, you can take a little look at it. If you're interested in doing some enriched work around that, I can give you like a worksheet talking about the calculations around that, but for now, we're just going to skip that. Okay, and we are going to go to page 91. Okay, and on page 91, we are looking at numbers of protons and numbers of electrons. Okay, numbers of protons and numbers of electrons. These are all neutral atoms. They're all neutral atoms. What does that mean if they are neutral atoms about the number of protons, which are positive, and the number of electrons, which are negative? If we know that those atoms are neutral, what do we know about the protons and the electrons? Yeah. They're going to be the same. And what do we know about the number of protons? How do we find that out? How do you find out the number of protons? Let's say you knew it was hydrogen. How would you go and find that? So many of you know this, yes. You look at the atomic number. So this chart is actually going to be really easy because those three are all equal, yes? Atomic number, number of protons, number of electrons are all the same. So that's page 91. That's going to be part of your homework. But before we do that, the rest of your homework is going to be page 92. So pages 91 and 92. And you are also going to study for your quiz on Wednesday. So this is quite short to give you some time to do some studying as well. Wednesday, remember, is a short day. There are parent-teacher interviews. Okay, so your day will end at 12:20 and there is no lunch on Wednesday. Okay, we go period 1, 2 break, and then we go 3, 4, and you go home at 12:20. Classes are 50 minutes long, 50. And then on Thursday, classes are just a little bit shorter and you get out at 2:05. So you guys get a very short Wednesday and a somewhat shorter Thursday this week.
How long is lunch?
On Thursday, it's the normal time, I think. I think it's 45 minutes. So. What's that? You still arrive here at the same time, yeah. Okay, so school still starts at the same time, so you don't actually need to know when the bells go. You just need to know you need to be here at 8:35 like usual, right?
I have a really short like when I draw a line, it like you have like stabilizers. Yeah, but also like I'd rather not do without stabilizers because it makes that line back, and also because when I'm going like my liner is so shaky. I forgot. I should switch it up, but yeah, there is a stabilizer. It's like up top. Well, I forgot where it is. Yeah, Google everything. Honestly, when I started Korea, I was just Googling everything. Same thing with Portugal because it's different today. Looks really similar, but it's different. Like my parents, they're like, "Oh, how do I do this?" I'm like, Google it. Google it, guys.
Yes.
Oh, I'm ripping the I should probably do both. You know, I'm responsible for doing it. Doing this. I'll do that. I'm joking. I am awesome. It's great. We just need to do it right now. Like when I get home, I will have to work on my visual. Oh my god. Maybe oh my god. What's it? I want to know more, honestly. It's so fun. I love it so much. I'm sure it's very fun. I'm so happy. You're so happy? Yeah. When I do my class, oh my god. I'm gonna be there. I need to take pictures, but not so I can get more active. So I took some titles.
Elements. Yes. Yes.
Oh yeah.
Yeah, I'll do that. Anyway.
I've been surrounded. She used to say it every day in science class. Then she suddenly went silent.
Do not surrender.
That's sushi?
She was like, this is so good. It's like, no, you have to give them out. Oh, right. I don't have a wrong number.
5 cents and 7 minutes.
You can. Yeah.
I can just think. Thank you for the answers.
Yeah, you get things and ask for it. Yeah, that's very good. Yeah, I don't really want that.
What's PB again?
But
You're really helpful. Thank you. Where is the lens?
oh,
Where is the lens?
because I thought that's what said, so we like talking about it. We got 30.
Oh my god.
Yeah, looking not cooked, but
It's okay. You're like him on lens.
So
we're going to be smart. That's me.
Oh,
It's not intensive because it's like really dangerous.
so how can you
Yeah. Yeah, it used to be. That's why we call pencil lead. But it's not anymore. Because it's like really bad. Oh my god. Bro. That one chest.
again, that's instead.
I was next to my son.
Well, I was on this. Get my phone. One, two. Yeah, I will look at the
Yes.
AP bio, like.
Who teaches AP Bio? It depends what year. Ms. Sin and Ms. Lamb. I think Ms. Lamb is teaching AP this year, so she'll be teaching 11 Enriched next year. And then Ms. Riley is teaching 11 Enriched this year, so she'll be teaching AP Bio next year. Yeah.
Do you teach any other? Yeah.
I teach AP Chem. So next year I'll be teaching the 11 Enriched, and the following year I'll be teaching AP Chem. Yeah.
Try to take.
Time to get your phone if you have not already done so. Thank you guys once again for being a hard-working group of students. I really appreciate it. It does good. It does wonders for me, and it does wonders for you as well. We have a very, very nice class average this year. You guys are doing a good job.
Yeah, probably back up. More flex.
That's so weird.
Try to stop it. You know, I was really bad and